What number is yours? Caitlin is definitely not number 23. Okay, solving radical equations. All right, so today we're going to be looking at solving different radical equations. So let's get right into it then. So when we solve equations, usually we're trying to get rid of something. Like in the warm-up, we want to get the x's on the same side or just solve for x. In these problems, we're going to solve for x also, or whatever the variable ends up being. But we have square roots in it, or radicals. So we need to get rid of those radicals. So what do I do to undo a square root? Square it. Okay, awesome. So we're going to take this, we're going to square both sides of the equation then. And when I square a square root, I get what's under it, right? Okay, so basically the square root, or the squaring, canceled out the square root in a way, right? Okay, so we have x left, and 5 squared is 25. Okay. Whew. Man, I hope they're all that easy. Okay. Okay. Letter B, 10 equals the square root of 2x. And here's one of the things we're going to be talking about as we're going through this, is that we have to check to see what's under the radical and what's not. If there's things that are or things that are not under the radical. But we always want that, I need to check, is everything here underneath the radical? Okay, if it is, I'm okay. I can work right from there and go ahead and square both sides. So 10 squared is 100, and that equals 2x. All right. That's good. All right. And then I have to do what? Okay, divide by 2. So x equals 50. All right, piece of cake, right? Okay. All right, so do letter B down here. Okay. Now, solving radical equations by adding and subtracting. Here's the first step you should always look for, one of the first steps. Okay, let's use green. Step 1. Okay, we want to get the radical by itself. And that means we're going to isolate the radical. So Justin, what does it mean to isolate something? Make it by itself, okay? Be alone, all alone, no friends to speak of, okay? Everybody's avoiding you. You feel isolated. You ever feel that way?
No.
When you're home alone and mom and dad have gone away and nobody to support you, okay? All right, so we want to isolate the radical. We want to get it by itself. So we always need to check, is there things on the same side as the radical that I can get rid of so that it's by itself? And in this case, we can see that this minus 4 is not under the radical sign. So the first thing I need to do here then is get rid of that 4. So if there's anything not under the radical sign that's on the same side as it, I need to get rid of that thing by isolating the radical first. Once I isolate the radical, then I can go ahead and solve it. And square both sides and find my answer. So we square both sides again. and we get that x equals 81. Now, when you're solving equations, there's one other thing you're supposed to do whenever you get to the end and you find an answer. What's that thing you're supposed to do? You're supposed to check it, right? So it's very important that you check your answer. So the square root of 81 minus 4, does that equal 5? So when I'm checking my answer to verify that it is exactly right, it has to look exactly the same. So the square root of 81 is, okay, so 9 minus 4 is 5, and 5 equals 5. Since 5 equals 5, it checks, and I did it right. Okay? But it's very important that you check them. We're going to get to a problem here later in a little while where it's very, very important that you check your answer, because if you don't, sometimes you have an incorrect answer. Right? So make sure you check it. Okay, letter B. Square root of x plus 3 equals 7. Is there anything on the same side as the radical but outside of the radical? No, okay, everything here is under the radical, right? Okay, since it's all under the radical, then my first step then is just to square both sides. So then we'll subtract 3, and x equals 46. So square root of 46 plus 3 equals 7. Square root of 49 equals 7. 7 equals 7. So it checks, did it right. Okay? But it's important to check your answers just to make sure in some fashion. You could even take your calculator, square root 46 plus 3, hit enter, yep, equals 7. Good, I used my calculator to check it. All right, but I did check to make sure it was correct. Okay, letter C. Did you notice which side you got that from? Which side? It was? Which side did you get it from? Guess what? That would be the right side. Yeah, because if you look at the look back there at the box, can you see it? Left side 1 through 15, right side 16 through 30. Okay? No wonder it's always been on the wrong side, because you weren't right in the head. Right, Megan? And stop stealing Mallory Underhile's lead and breaking it. She said you and, who else was it? I forgot. We're taking her lead out of her pencils and just breaking it in little pieces. Oh, you would never do that, I know. Okay, so we look at this radical equation. Okay? Square root of 5x plus 1 plus 6 equals 10. Are the things on the same side as the radical that aren't under it? Yes, there is. There's a plus 6, right? So the first thing we have to do is get rid of that plus 6 and undo that adding 6 and subtract it. So it's very important that you do your radicals correctly. I noticed that we have I think it's 1 or 2 students in here that will do this. Just put a little line there to designate the fact that that closes it off, and that's great. Okay, you can do that. That works fine. Okay, so if there's others who would like to do that, that's okay. I don't usually do it. I just make sure my radical sign goes where it should. So, okay, now, since I have isolated the radical here, I can now square both sides. That eliminates the radical. And I have 5x plus 1 equals 16. And then it's just a matter of solving this simple linear equation. Subtract 1. And divide by 5. And once again, very important that you check your answer. So I can do this one on my calculator also. Square root 5 times 3 plus 1 is under the radical. And then press the arrow key so that it's now outside the radical, plus 6. And does it equal 10? Yes, it does. So I did it correctly. If I did it on my paper then, square root 5 times 3 plus 1 plus 6 equals 10. 15 plus 1 is 16, so square root of 16 plus 6 equals 10. 4 plus 6 equals 10, and so 10 does equal 10. All right, it does check. Right, so you can do it either way, but do make sure you show your work and do some checking. Okay. So let's do, let's do C then. Let's just take the most challenging one and do that. Now, still, so we have a different example here where we're going to have to either multiply or divide to start the problem. So the first thing we need to do, once again, is we want to isolate the radical. That means that I want this thing here by itself. Is that 4 underneath the radical? No. So the first thing I need to do is get rid of it. Now, you could do this problem without getting rid of it first, but to guarantee your success, it would be a good idea to get rid of it first of all. So we're going to divide both sides of this equation by 4 because we're going to undo that multiplication by 4. So we get the square root of x equals 8. And then square both sides. So x equals 64. So 4 times the square root of 64 equals 32. 4 times 8 is 32. So 32 does equal 32. I checked it, got it right. Okay. Having a good day. I'm getting them right. So if we start out multiplying or dividing by the radical also, our first step is going to be to undo that multiplication or division. Okay. So here we got letter B. Find the radical. Maybe for you it might be a good idea, you know, that maybe I circle it or highlight it to make sure I know what's under the radical, right? So that I don't assume that something else is. So in this problem, you have to make sure that when you write it down, you don't write it down as square root of x over 2. Okay? Make sure you don't copy it down wrong. Okay? That's the first step, is double check your work. Okay? So here, we need to undo this division by 2. So we're going to multiply by 2. Cancel those 2's out. 12 equals the square root of x. I have isolated the radical, got it by itself. Square both sides. And we get x equals 144. Now, if you're checking this one on your calculator, you need to be careful here. You could do this in more than one step. I'll say the square root of 144 first. I'll just hit enter there. Okay, what's happening to that? It's being divided by 2. All right, and that does equal 6. So it is correct. All right. Or you could use the fraction bar. Okay. Put the square root of 144 in the numerator, 2 in the denominator, hit enter, and I still did it right. Okay? But make sure you're checking your answer. Okay, I want you to do letter C. Do letter C here. Well, sometimes we end up with more than one radical. We might have 2 radicals we have to deal with. Okay? So, here's, if we have 2 radicals, okay, we want to get them on opposite sides and then square it, both sides. Okay. So if we have 2 radicals, we want to get them on opposite sides of the equal sign, and then we want to square both sides of the equal sign then. But we have to make sure they're on opposite sides first of all. Otherwise, you have a mess. Okay. So here we have the square root of 2x minus 1 equals the square root of x plus 7. All right, so a little note to yourself there. Okay, if there's 2 radicals, I want them on opposite sides, so then I can square both sides. So we get 2x minus 1 equals x plus 7. So what are we supposed to do when we have a variable on both sides? Okay, all right, we want to get rid of one of them. Which one do we want to get rid of? Okay, we want to get rid of the smallest one, right? Okay, so what's smaller, positive 2 or positive 1? Positive 1, all right? So we're going to subtract x from both sides first. Oops. So we get x minus 1 equals 7, and then add 1 to both sides. So x equals 8. So it's still important that we check our answer. Square root of 2 times 8 plus 1, does that equal the square root of 8 plus 7? Oops, that's minus 1. Thank you. So we have the square root of 16 minus 1 is 15, and 8 plus 7 is 15. So both sides are the same. It checks. I did it right. Okay. Okay. Letter B. Okay, here we have an equation with 2 radicals again. So we said, if we have two radicals, we want to get them on opposite sides of the equal sign. So what does that mean I'm going to do in this case then? Okay, we're going to add the square root of 6 to start with. So plus square root of 6 plus square root of 6. What's nothing plus the square root of 6? All right, so we get the square root of 5x minus 4 equals the square root of 6. So now that I have the radicals on opposite sides, I can square both sides then. So 5x minus 4 equals 6. Add 4. 5x equals 10. So x equals 2. Now when I go to check my answer, just remember, always go back to the original. Square root of 5 times 2 minus 4 minus the square root of 6, is that equal 0? Okay. 10 minus 4 is 6, square root of 6 minus square root of 6. All right. So 0 does equal 0, so that does check. So when we have two radicals, make sure they're on opposite sides. Because if you don't, all right, whatever you get, unless you're very lucky, will not be correct. All right, sometimes you can be lucky and still get the right answer, but not very often. Okay, last ones. Example 5, extraneous solutions. How many of you have heard the word extraneous before? Not extraneous, extraneous. All right, Justin, you've heard it before? Not sure now, are you? Okay, because he mentioned the other word. All right. Extraneous solutions are this. These are solutions that I get but don't work. Okay, there's solutions that I get but don't work when checked. Right, and we're going to see how that happens here. And first of all, should be some common sense that comes involved in this, okay? All right, how many of you think you have common sense? At least a little bit, maybe an inch worth, okay? All right, okay, all the boys and only a couple of the girls. Ooh, that's not good, okay? All right, now, I want you to think about this for a second. Let's look at this very first problem here. It says 12 plus the square root of 6x equals 6. Now, how many answers to this equation do you think there are? One? Okay, Nolan, you said none? Why not? Does that make sense? Okay. This answer I get here can only be positive, right? You cannot get a negative number when it says plus 6, the square root of 6x, can you? All right. So if I take 12 and I add something to that, I'm only going to get a number larger than 12, right? Okay. So is it possible for me to get 6? No, it's not. So this is a problem where the answer is no solution to this. And we're going to show you why that is in just a second. Yes, sir. Doesn't matter. The plus sign here would have to be a minus sign. Has nothing to do with what's inside there, because you can't get the square root of a negative number. Okay? So let's check it out and see what happens. So do we have, is the radical isolated right now? No, it has this additional 12 here, okay? So my first step is to get rid of the 12. So we get the square root of 6x equals negative 6. Okay, all right, so this should tell you that I can't take the square root and get a negative number. Okay. So we square both sides. So we get 6x equals 36. Okay, I can handle that. All right, and we divide by 6, and x equals 6. All right, so I got a nice positive number of 6. Great, I love 6. It's a good number. The only problem is, when I check it, I get 12 plus, well, what's the square root of 6 times 6? 6, okay? 12 plus 6 is 18. 18 does not equal 6. So that means that that doesn't work. So it's no solution. This is what's called, the 6 here is what's called an extraneous solution. A number I get, but does not work. If you look, that's a good question. If you see a problem like this, and you can see that it's obvious because 12 plus something cannot be equal to 6, then you can say that I recognize this doesn't work, no solution. Okay? You have to tell me that, though. You can't just, there's no reason to do all the work if you recognize it. If you don't recognize it, then obviously you're going to do all the work. So, okay, let's look at B here. X equals the square root of 2x plus 3. All right. Do I have the radical by itself? Okay, and I only have one of them, right? So I can go ahead and square both sides. So x squared equals 2x plus 3. Well, this is a little different. What do we do here? We have a quadratic equation. Okay? We did these the very first week. Okay? When you have a quadratic equation, you have to get everything on the same side so it's equal to 0. So I have to subtract 2x and 3 from both sides. I now have a quadratic equation, and it's equal to 0. When I have a quadratic equation that's equal to 0, then I can do what? I can solve it, but how do I go to solve it? I need to use a word that starts with the letter F, and it's more than 4 letters. Okay? All right? Factor. Okay? We have to factor it. So what are the factors of negative 3 that add up to negative 2? 6, almost. Okay? 3 and 1. So, oops. Are this 3 and this 1, are they both positive, both negative, or what? Okay, one's positive, one negative, get negative 3. Which one's which? Okay, negative 3, positive 1. All right, equals 0. All right. So everybody remembers how these works then, right? The answer is the opposites, right? Okay, 3 minus 3 is 0. Negative 1 plus 1 is 0. Okay. So we get x equals 3 or negative 1, right? So let's check them. Start with 3. So 3 equals, what's 6 plus 3? 9. So 3 equals 3. All right, we're good. The 3 works. Okay. Hot dog. Let's try the negative 1. Let's see, negative 2 plus 3 is negative 2 plus 3 is 5. Okay, how about positive 1, all right? So what's the square root of 1? Does that equal negative 1? Oh, no, it doesn't. So negative 1 does not work. So my answer is just x equals 3 because negative 1 is an extraneous solution. Now, okay, here's the thing. I knew it was right away because of this just being x here. That I knew that if I got a negative answer, it wouldn't work because the right-hand side is only going to be positive. Okay? So the negative 1 wasn't going to work because the right-hand side was only going to be positive, and so the left-hand side couldn't be negative. All right, so I could see that right away. Are all of you going to be able to see that right away? Not necessarily, so just plug it in, check it, see if it works.